Hi, welcome to this technical update on IBM Spectrum Protect version 8.1.2. My name is Trisha Jiang, and I'll be working with my colleague Sean Sperry. In this presentation, we'll cover the new features in the Server and Operations Center, the client, HSM for Windows, and HSM on Unix. I'll then turn it over to Sean to cover the VE and Spectrum Protect data protection for Windows new features. 8.1.2 announced on August 8, 2017, and GAs on August 11, 2017. In 8.1.2, you can now utilize client deployment to seamlessly and securely deploy Spectrum Protect client updates. 8.1.2 offers this ability via the command line, and this replaces the existing client push mechanism that was in the admin center. We are looking at integrating this in the future into the Operations Center as well. With the backup archive client updates, you can update clients that are greater than or equal to version 6.4.3 up to the most recent version, which is 8.1.2. Now, the backup archive clients do have to have a client acceptor daemon scheduler running. The 8.1.2 version of Spectrum Protect supports the platforms and operating system versions that are supported by Spectrum Protect version 8.1. If you are running the 7.1.8 release, that will support the operating systems versions in version 7.1. Now, this is not a greenfield install, and this does not work with cluster node deployments, TDPs, HSM, or storage agents. Also, you can't use this technology to either downgrade or to do the initial configuration and modification of a client. There is a minimum amount of free space required on the client, and I'll show you that here in a minute. And password access does have to be set to generate. There is an additional tech doc on this if you want to take a look at that, and that's at this link here. The steps that are required in order to do the command line client deployment is, first of all, you'll go through and configure the Protect server. Then you'll download the client packages from the client maintenance site and place those on the Spectrum Protect server, at which time those packages will then be archived into the Spectrum Protect storage pools. You'll set up a schedule for individual clients on when and what you want to be deployed. And when that schedule deploys, the client will receive the deployment manager package. And after that's expanded, it will actually parse the instructions, identify the client package that's needed, retrieve that client package from the Spectrum Protect server, and then do the upgrade. At which time it'll report back to the Spectrum Protect server where you could view the deployment results. So let's take a look at those individual steps. In order to configure the Spectrum Protect server for client deployment, you will need to create a directory, and we're going to call this the import underscore directory on the Spectrum Protect server. And this is where the deployment packages are going to be stored. Next, you'll define an IBM deploy client import dev class, and you'll define a storage pool. Now, this storage pool can either be file or disk pool, and it can be either a new or existing storage pool. At this point, containers are not supported. So you'll do the define dev class and the define storage pool. And then you'll define the policy domain, copy group, and default management class. And the important piece here is when you do the define copy group, you will be able to specify how long to retain the deployment packages. Finally, you'll set the high-level and low-level addresses for the server if you already haven't done that. Next, you'll actually download the client packages and place them into that Spectrum Protect server directory you set aside. And all of these packages are going to be available out on this FTP site here. Now, there are two deployment packages for each upgrade. One is the deployment manager package, and one is the client upgrade package. And we've separated these so that if all we're doing is upgrading the version of the client, it's not necessary to update the deployment manager as well. So you'll download whatever platform you're looking for, both of these packages, into your IBM Deploy Client Import directory. Then you're going to import those packages into the Spectrum Protect server storage pool. And you will run this import node command, and you'll run it both for that deployment manager package as well as for the upgrade package. And you can run a query process, and that'll show you the status of that import. And if you want to verify that the packages are in the location where they can be accessed, then you can run this select command. Next, you'll need to set up a Spectrum Protect server schedule. And the first thing you'll need to do is decide which clients you want to do the automatic deployment for. If you're using server prompted, then as your scheduling mode, you can immediately deploy the updates by using the start date equals today and the start time equals now. Now you will notice we've got a couple different options here. So depending upon the type of platform you're pushing the clients out to and the version of the package, you're going to have some different options to put into the schedule. You will need to have the retrieve location, depending on the platform, the package identifier, and notice this package identifier has a version level. In this case, it's 8120. And you'll also need the client deployment name. This client deployment name is specific for the different types of platforms, Unix, Windows, or Mac. So you'll go ahead and do this define schedule name, identifying your existing clients you want to push the data out to with the associate command. And then optionally, you can update the target level of the deployment package later on when, for instance, we introduce an 8121, 8123, or whatever. You want a different level of the package to update. Now, once that schedule kicks off, then the schedule will take the deployment manager packages and push them out to the client machines. And this is where you do need some additional space on the client machine in order to receive those packages. Once the client deployment package has been received via that scheduled process, it will start the deploy manager. It'll parse the instructions, identify the correct client package that we want. That client package will then be retrieved from the Spectrum Protect server and brought back. We'll run the upgrade operation, and then finally we'll report back to the Spectrum Protect server about the results, where you could view them utilizing the select command. Okay, so that was the new ability to use the command line interface to upgrade clients. The next thing we're going to talk about is directory container pool encryption. Now in 7.1.3, we introduced server-side encryption for cloud containers. In this version, we're introducing it also for directory containers. And this will be an AES 256 GCM encryption. And when you put data into those containers, they will be inline deduped, then they will be compressed if you have compression turned on, and then we will encrypt that data. Now, in order to enable this encryption on a directory container, you'll first of all need to make sure you've set your server password and you've set the DB recovery protect key equals yes. The reason for that is these keys are necessary in order to unencrypt the data that's being stored in those directory containers. Next, you'll either want to update or define a container storage pool and set encrypt equals yes. And here in the blue, you can see us updating the storage pool to do that. Now the keys are being managed by the Spectrum Protect server, and that's why we do need to run this DB backup to protect those encryption keys. And so you can either have that as a scheduled command or run it as a command line, or from the OC, you can also go into the servers and do the backup from there. Now the master key protects the directory and the cloud encryption keys, and it is needed to restore the encrypted pool. So if you lose that, you will not be able to restore this data that's been encrypted. So how does server encryption differ from our previous versions of client-side encryption? Well, server-side encryption controls encryption at the storage pool level versus client encryption, which controls encryption at an object level using this include.encryption and encryption type options. The server encrypts at a chunk level versus the client, which encrypts at a file level. And then additionally, the server uses 256 byte versus the client's AES 128 256 or DES 56. So the biggest difference here, if you use server-side encryption, that data can also be deduplicated. Versus if you encrypt on the client side, then that data cannot be deduplicated either by the client or the server. So server-side encryption is definitely the preferred methodology. We've updated the query storage pool format equals detailed to show if encryption is turned on and the percent encrypted. Likewise, if you do a query acklog, you will see this ANR 0982I message showing that server-side encryption is being utilized. If you run the query dedupe stats for that storage pool format equals detailed, you will see the encryption extent space used, the percentage, the extent count, and the unencrypted extent count. We are now able to take an existing directory container storage pool and run encryption against it. And so you would run this new command, encrypt storage pool, the storage pool name, the number of processes you want to dedicate to this, and then you can either choose preview equals yes, and you can also choose wait equals yes or no. If you issue a query process, you will see that a main process and worker processes are running for this. And if you do a query acklog, you will see down here an ANR 4813I message once the encryption for that existing directory container pool has completed. Now, if you are using encryption on your directory container pool, you do need to look at how that will impact replication. So here is our source servers down here, and then we have our target servers going across. So if your source server is an 812 server and you do have it encrypting data as well as your target server, then we will simply send the encrypted chunks as they are to the target server. If we do have any non-encrypted chunks on the source server, once it's sent to the target server, it will be encrypted. If you have encryption set to no on the target server, then the encrypted chunks on the source server will still simply be sent as they are to the target server. And any non-encrypted chunks will simply be sent to the target server but will not be encrypted over there. And if your target Spectrum Protect server is using a legacy server, then the server encrypted chunk is decrypted on the source server before being sent over. And any non-encrypted chunks are simply sent as they are to the target server. If your source is a legacy server and it's sending it to a target server that's 812 with encryption to yes, then the chunk is encrypted once it reaches the target server. And if your source is a legacy server sending it to 812 with encryption set to no, then the chunk is simply sent as it is to the target server. So if you turn on encryption for your directory container storage pools, be sure to look at where those directory container storage pools are replicating to and what the encryption status is in those pools also. Okay, the next feature in Spectrum Protect server is the addition of the cloud container support for Microsoft Azure. This is an off-premise cloud container, and we are supporting the Microsoft Azure blob storage. Microsoft Azure has its own specific connection. It's not S3, and we are going to be able to use the Microsoft Azure specific connections only with the Microsoft Cloud. We're not supporting the hardware appliances that also use the Azure specific connection. You do need to carve out some space on your Spectrum Protect server disk to be in hybrid disk directory so that we can use that as an accelerator cache. Inside of Azure, you have the option of choosing either hot or cool storage, and that will be configured in your Azure storage account. Spectrum Protect will work with both hot or cool. The Microsoft, however, charges more for recall of data from cool. And if you do make a change, Spectrum Protect doesn't notice any difference, but you might notice a difference in your billing from Microsoft. Let's take a look at how Azure storage accounts is similar to S3 buckets. Azure storage accounts are basically equivalent to buckets, but they're set up outside of Spectrum Protect. The storage account name is used when addressing the blob of storage in the URL, so you do not use the bucket parameter on the defined storage pool or update storage pool command inside of Spectrum Protect. If you issue a query container, you will see it does not display the bucket name as part of the container name for the Azure storage accounts. Now, Azure also has this concept of a shared access signature called a SAS token. And SAS tokens are used as the password in Spectrum Protect when we do the define storage or update storage pool commands. And this means we don't need a user ID. And it's only the SAS tokens that we use for authentication. However, the SAS tokens inside of Microsoft are configured to expire on a specified date. And so we recommend you set that as a long or infinite expiration. The initial release of Spectrum Protect will not report or monitor on any approaching expiration of your SAS tokens. So if a SAS token does expire, Spectrum Protect won't be able to communicate with that Azure until that token is replaced with a new one inside of the Spectrum Protect definitions. If you're using command line, this is the define command you'd use for Azure containers. And the difference between this and other cloud storage pool definitions are the cloud type is set to Azure, there is no identity parameter, and the password parameter is using the Azure SAS token. If you were to go into your Microsoft Azure account, then you can create a storage account like you see over here, and you would add in a name for that storage account. You would want that account kind to be a blob storage. You can determine what type of performance you use, whether it's standard or premium, as well as the access tier, where we support both cool or hot, the difference being how Microsoft charges for them. For encryption, set that to disabled. We'll be using our own Spectrum Protect server-side encryption. And then for the location that you choose, we suggest you set the location closest to wherever your Spectrum Protect server is. Then you'll want to copy the primary blob endpoint service URL that's provided. And that will be needed by the Spectrum Protect when you're setting up the Azure containers. You'll also need to create a SAS token, and then you'll want to go ahead and copy that SAS token over as well. Inside of the Spectrum Protect Operations Center, we do have a nice wizard that allows this process to be semi-automated. If you go to the Operations Center, Storage Pools, and click on the plus Storage Pool button, that will start this Add Storage Pool wizard. Here you can see if you choose an off-premise cloud, you now have Microsoft Azure as an option. And you'll see here for the details where we put in the SAS token as well as the blob service endpoint. The summary of what I just talked about is we now support Microsoft Azure as a off-premise cloud container. On slide 22, we now have a new command inside the Spectrum Protect server. This is the Query Protect Status command. And when you issue Query Protect Status, it'll show you how many deduplicated extents are in a given pool. And it shows how many of those have been protected using the Protect Storage Pool command, which replicates the data over to a secondary server. Now, throughout the day, as you back up new data to those containers, then there are going to be more and more extents which are not protected until you run the Protect Storage Pool command again. So you will see this % protected drop throughout the day until you run your next Protect Storage Pool command, and those extents are then replicated over. So this is just a great way to check and make sure that your extents are being properly replicated over to a secondary server using the Protect Storage Pool command. On slide 23, 812 brings pLinux server Little Endian support, and the cross-platform database migration is not supported, where you do a migration from Red Hat Linux Big Endian to Red Hat Linux Little Endian. The pLinux Little Endian support is limited only to new installations and deployments. On slide 24, another new feature is the ability now to do NDMP backups to containers for your NetApp devices. So now NetApp filers can do backup, deduplication, compression, encryption to a container pool. This can be either a directory or a on-premise or off-premise cloud container. And you could utilize either the backup node, restore node from the Spectrum Protect admin, or the backup NAS, restore NAS from the backup archive client. you do have to have your server option enable NAS dedupe set to true. Some of the caveats on this support is your table of contents so that you can do file level restore must be written out to a legacy storage pool. That cannot be written out to a container. Also, snapmir is not supported for containers, nor is your snapdiff command. And currently only NetApp is supported going out to container storage pools. We don't support EMC or any of the other filers. And this is because NetApp freely documents their BSD dump format. So we were able to go in and utilize that dump format and work with it so that it would write out to our container pools. And the other filers don't have this type of open documentation. Some other caveats: your convert storage pool does not work for pre-existing NAS data, and your protect storage pool can be utilized for NAS node data, but your replicate node is not supported. So what this means is that you would have copies of the data over on the secondary server, but the meta information would not be there. So the protect storage pool on the target server could be used by the source, for instance, to do a repair of a damaged container, but it cannot be used for a client restore if you had a failure on your primary server. Okay, now we're going to change pace in the Spectrum Protect server, and we're going to look at a group of enhancements that focus around security. Spectrum Protect always strives to be a secure by design product. And this is because a lot of government, enterprises, IT landscapes, they're continually changing and continually are looking to address different types of regulations like the EU's GDPR or the US federal government's on-ramp or NIST or HIPAA or other regulatory requirements that have a lot of say in how data is being secured. Spectrum Protect is maintaining assets that have to be protected. These assets include things about identification, they include the data that we're storing and protecting. And so we need to be able to protect those assets inside of Spectrum Protect against various levels of threats. And this might be, for instance, an application where we need to make sure we give them secure access and that we are protecting both data at rest as well as data in flight. Likewise, we want to be able to protect those assets against people who might be disgruntled or who might be hackers or who might be utilizing some type of dark web tool to exploit the data. And likewise, we want to do all we can to prevent technology hacks like worms or bots or virus or malware against the data that we have in there. So with this in mind, we have made some updates to 8.1.2. Those updates revolve around how the local credentials are stored and managed inside of the Spectrum Protect server and clients. And we have a product-wide adoption and exploitation of TLS 1.2 to secure the point-to-point communication that occurs between the Spectrum Protect servers, clients, and administrators. So let's start by looking at slide 26 and talking about the master encryption key. In 8.1.2, a master encryption key is automatically generated at the server start. And this master encryption key is designed to enhance the system security. It is managed by the IBM GS kit for best practice security. You are no longer required to have the server password set before the master encryption key is generated, as was necessary in prior releases of Spectrum Protect. And the key's database password is going to be stored in an obfuscated form in a password stash file called dsmkeydb.sth. Now, if you never set up a master encryption key previously, then when you upgrade to 8.1.2, a master encryption key is going to be generated and stored in the new key database, dsmkeydb.kdb. If there's an existing master key out there already from previous versions, then the key is going to be migrated from the dsmserve.pw file to this new KDB file. Now the passwords are being protected using random passwords out there, and the ownerships and permissions of both the key databases and the stash files are now set to give only the instant user access to them. Likewise, our server SSL certificates, which I'll talk about here in a minute, are still going to be stored in the cert.kdb trust store, and they can be accessed by the stash file cert.sth. Now, you do need to protect these cert and key databases. And so by default, the backup database will protect the master key encryption. This is critical because without that key, you cannot restore the database. Now, the dsmserv.pw file that we used to utilize to store the master encryption key is simply no longer going to be used. So let's look at some more details on this. On slide 27, first and foremost, if you lose the master key, you lose all the data stored in the encrypted container storage pools. Likewise, if you lose the master key, you lose everybody's password. So it is critical that you protect this master key. In 713, the backup database command optionally backed up the master encryption key. And that was only required if you were using storage pool encryption. But now in 812, the backup database command will, by default, has been changed to always back up the master key. Now, the database backup password will be required, and following an upgrade, the backup DB will fail until the database backup password has been specified. So if you have not previously set up a database backup password, you need to do this. Otherwise, your backup databases are going to fail once you upgrade to 812. So we have two ways of doing this. The default option is to back up using the database backup process. And all you have to do is do the set DB recovery, protect key equals yes, and then give it a password. Or you can do backup database, protect key equals yes, and assign it a password. And so this is going to be the default. The reason is it's easy and it just works. And we're worried that administrators maybe won't bother to manually back up the DSM key DBs. And so we wanted the default to automatically do that. You do want to choose a strong password with a minimum of 8 characters with a mix of upper and lower alphabetical characters, numbers, and symbols. Do not forget the password, okay? The master encryption key cannot be restored without it. So this is critical. If you want a little bit more expert option for this backup, then you'll want to manually back up the dsmkeydb.kdb and the dsmkeydb.sth. And this could be a little bit more secure than the default option we just talked about, because by the definition of a best practice, you would want to transport the encrypted data via a different channel than the encryption key. And so by putting the master encryption key on media with data that it protects, even if it's encrypted, that kind of violates the principle. And that's what the default option did. So with the expert option, the key database files, because they typically do not change, you'll likely do this operation just one time. You'll place copies of these at each of the disaster recovery sites. And ideally, you would transfer the .kdb files separate from the .sth files. Now, to prevent the master key from being placed on database backup media after you've manually transferred the files over, you would then do the set DB recovery protect keys equals no, or backup DB protect keys equals no. So what I just showed you was two different options for protecting your master encryption key. Default option is a little less secure because it sends the key along with the data that it protects, versus the expert option, which requires a little more manual interaction and requires you to manually back up and transport the dsmkeydb.kdb and dsmkeydb.sth over to your recovery site. We've also made some changes to the way that passwords are being protected. First of all, on the Spectrum Protect server, we've increased the encryption strength for the nodes and the admin passwords. So previously it was just using 128-bit AES, and now in 812 and on, we'll be using 256-bit AES to protect that node and admin password. This does not affect the passwords if they're being managed by LDAP. We do use AES 256 GCM, Galileo's counter mode, instead of CBC, cipher block chaining. And that's because GCM adds a message authentication code called a MAC that allows for detection of corruption or tampering. We also use a random encryption key. These are unique for both the node and the administrator passwords. Both keys, however, are stored in the database along with the passwords. And before we store that, each key is encrypted using the server master encryption key. Next, passwords that we've changed. SSL. The SSL passwords are no longer tracked by the Spectrum Protect server. We now use the stash file called cert.sth, and we no longer support the query SSL keyring pw command, the set SSL keyring pw, or the delete keyring commands. So that's changes to how we deal with the SSL passwords. On your Spectrum Protect clients, these would be the customer's production machines. Those passwords are now being stored in key stores that are created using the GSKit methodology. So tsm.kdb holds the encrypted passwords, tsm.idx is an index into the tsm.kdb, and tsm.sth holds random obfuscated encryption keys that are used in the tsm.kdb. Now in Unix, previously the passwords were stored in the tsm.pwd file in the default folder. Now in version 8.1.2 and above, the passwords are stored in the same location as the old tsm.pwd files were stored, but in these new files. In Windows, on 8.1.0, the passwords were stored in the registry, and now in 8.1.2 and above, the passwords are stored on the file system in the program data, Tivoli, BAC client nodes, and then in those files there. Okay, so changes to how we are protecting our passwords. There are a couple special cases here. If it's a VE GUI Spectrum Protect server administrator password, that will be stored in this directory. And password locations for clients in cluster environments, that is if you've set cluster node yes, then the password files are stored in a subdirectory of the client option files. One of the biggest changes that have come with these secure password pieces is that TCA, Trusted Communication Agent, is removed in 8.1.2. So previously, TCA allowed non-root users to perform operations that required access to the password stored in the root-only tsm.pwd. In 8.1.2, the root user can use the following methods to allow non-root users to manage their files, but TCA is no longer supported. So either the root user can simply set up a help desk where the root user themselves runs all the backup and restore operations. So that would require any non-root users to contact the root user to request certain files to be backed up or restored. Or the root user could set up an authorized user methodology. This would have the non-root user given read-write access to the passwords that are stored in the password dir option. And then you'd point to those password locations as readable and writable by the non-root user, and then allow the non-root user to back up and restore their own files, use encryption, or manage the passwords via the password generate option. So, takeaway on this one. If you are currently using trusted communication agents, that's no longer supported in 8.1.2, and you will need to make some changes so that non-root users access and back up their own files. The next security enhancement is the utilization of TLS 1.2 as the default for communication between the Spectrum Protect servers, admins, operations center, clients, and storage agents. Previously, we did support SSL, including TLS 1.2, but it was optional, and the setup was manual, and things like the server had to be restarted. So in 8.1.2, we've streamlined and automated the process so that we will automatically try to exchange certificates between the servers, the admins, the operations center, and the clients. What happens is when we upgrade to 8.1.2 and the Spectrum Protect server starts up and a session is started, the server is going to check for copies of certificates in its own server database. We will be keeping copies of certificates in the Spectrum Protect server's database. And then we will communicate those certificates and exchange them via server-to-server SSL and utilizing the server-to-server password that's set up when you do Spectrum Protect server-to-server communication. The certificates that are exchanged on the Spectrum Protect server, we will place them in the cert.kdb, and in the admin and client, we'll place them in the dsmcert.kdb, and for the operations center, we'll set them in the GUI-truststore.jkm. So these are 3 trust stores that will automatically be set up by Spectrum Protect and will be utilized for the TLS 1.2. When you define the server with cross-define equals yes, that will allow for the bidirectional exchange of these certificates. One thing you do need to be aware of is for storage agents, you will have to manually configure them. They are not automated at this point. Certificate exchange automation is available only for sessions between the 812 server and using the V2 authentication. And we're going to talk about that here in a minute. Certificates can be manually exchanged and using the GSK8 kit. In fact, all of our certificate exchanges are based upon the GSK kit that Spectrum Protect utilizes, and this is provided by IBM and is a top-of-the-line security package. If you do utilize CA signed certificates, those are also supported. I do have a YouTube out there that covers how we go about doing the certificate exchange, and I show the automated process, but underneath the covers I show you what's happening so you can see some of the queries and see what's changing in these certificate stores during the exchange of certificates. So check out that YouTube. There's also a tech note out there that goes into deeper information on the TLS piece. What we're setting up by default is only for the communication. If you want to also encrypt the data that's flowing across, you can set up on the server the defined server SSL equals yes, and then in the client dsm.sys file, you would set SSL yes. So this is supported, and now you will not only be encrypting communication, but you'll also be encrypting all of the block objects, and those will also go over SSL. When it comes to the ports that this communication occurs on, we are now using the default TCP port and TCP admin port to utilize that both for TCP and SSL. If you set the SSL TC port or SSL TCP admin port options, those will remain specific just for SSL communication. Okay, on slide 31, I have 2 charts here. The first chart shows the different trust stores that are out there, and then which certificate gets put into that trust store. So here on your primary Spectrum Protect server, we have a certificate trust store called cert.kdb. And if you are doing server-to-server definitions, we would place the target server's certificate in there. Likewise, on the target or spoke server, we'd place the primary server certificate. For the operations center, on the initial install, we will place the hub server certificate in that GUI-truststore.jkm. If you're defining spokes, we'll also place the spoke server's certificate in that trust store. If you're utilizing admins or clients to communicate with the Spectrum Protect server, then in the client and admins trust store, which is dsmcert.kdb and resides directly on the Spectrum Protect client, we will place the server's certificates in there. This second chart down here shows you the different handshakes that go on between the different entities. And so here you can see if you are using client-to-client communication or server-to-server communication, this is the type of TLS handshake that's occurring, versus if you're using client-to-server handshakes below. On slide 32, when we set up this TLS 1.2, we needed a way to enforce it. And so we basically have 2 pieces that need to be in place in order for the TLS 1.2 to work between the different entities. And an entity could be a Spectrum Protect server, it could be a node, it could be an admin, it could be an operations center. And the first of these enforcement pieces is a new parameter called session security. And this session security can be either in strict or transitional. Strict means that we are capable of enforcing the given level of security, and that given level of security is currently TLS 1.2. And so something will be set to strict if, for instance, we have successfully exchanged the TLS 1.2 certificates. Now, transitional is the default. So when you first upgrade to Spectrum Protect 8.1.2, or when you're using lower levels of Spectrum Protect, the transitional state basically says no security method is currently being enforced. However, we are open to looking at different methods. So if somebody comes knocking on that server's door and says, I'd like to exchange a TLS 1.2 certificate, then the entity that's in transitional state will be open to exchange certificates and eventually be placed in strict. When you do like a register node, register admin, define server, you will see this new parameter, the session security, and same with update node or update admin or update server. You can also, if you wanted to manually manipulate the session security, that's one place you could do that. If you want to see what state a entity, which once again could be a server, node, or admin, is currently in, you can issue these query or select commands, and that will show you the output. And so for the session security, you would either see transitional or strict. And for the transport method, it'll either be a question mark, which means that these entities haven't successfully authenticated with anybody yet. It'll be none. It'll be SSL-TLS 1.1 or SSL-TLS 1.2. And the select columns are named session_security or transport_method. So for instance, you could do this select command here, select star from admins, where session_security equals transitional, and that would show you all of your admins that are still in transitional state. The second piece is that underneath the covers, we've changed the way that we communicate and what type of information we exchanged when a server connects to another server or when a client connects to a server. And we're tracking this communication obviously with different verbs, and our new verbs are going to exchange the minimal amount of information that's necessary to be able to establish the identity of the other entity as soon and as early as possible. And then once we've established this identity, the subsequent exchanges occur with confidence that we know who we're talking to. Additionally, information that's sent to an unauthenticated entity is going to be limited. So for example, if you have a client trying to connect into a Spectrum Protect server and it gives the wrong password or it gives the wrong node name, we're simply going to send back an auth_failure return code. Instead of sending back information like, oh, wrong password, try again, we're not going to give back that kind of detail. However, if you do provide the correct ID and correct password, then we can give you more information. And inside of the Spectrum Protect server activity log, we're still logging why that session failed, that session connection failed, so that if you do need to troubleshoot it, you can find the information there. New way of establishing connection, sending across less information, really making sure we know who we talk to. And so this new protocol we call our V2 authentication protocol versus our legacy protocol, which we would use in servers or clients prior to 8.1.2. So with 8.1.2, in order for us to utilize the new TLS 1.2 communication, we have to have two things occur. First of all, we have to make sure we're communicating with this new verb exchange, and that occurs if you're at 8.1.2 or above. And then the second piece is to make sure that we've actually exchanged certificates and that we've gone from a transitional state to a strict state. So here you can see with the SSL-TLS protocols, as long as we are utilizing TLS 1.2, which is the CERT 256.ARM certificate, then we've met the strict requirement. And with the authentication protocols, as long as we're utilizing the version 2, and that would be when we're talking to 8.1.2 or 7.1.8, then we've met the strict requirement. And so once both of these strict requirements are met, you will see the session security being updated from transitional to strict. And now anybody who tries to communicate with that entity has to be also at that strict level. Now remember, right now we're at TLS 1.2 as our strict requirement, but in the future there might be a TLS 1.3 or TLS 2 or who knows what. And so this strict requirement might change in the future depending on the different types of SSL verification that's available. So with this new authentication protocol, where we're using the new verbs to allow for the query and transmission of the certificates, and we make sure that both the servers or the server and the admin are moving from the transitional state into the strict state once the exchange of the certificates occur. Now, in order for an exchange of certificates to occur, both of those entities have to currently be in the transitional state. We use basically the same verbs for the communication protocol, but just with slightly different input fields for our client-to-client, as well as our trust on first use that we use with Operations Center, as well as our server-to-server certificate exchange. So depending upon the different type of entities that's connecting into each other, those verbs will be slightly different. Once again, if you do have storage agents out there, you will need to manually set them because as of 8.1.2, we don't automate that procedure. So when you first upgrade 8.1.2, you will find all your servers are in a transitional state, and then as the entities connect in, and as we verify the certificates and verify the protocol, then they will be marked strict. If you have servers that are below an 8.1.2 level, they will remain in transitional state until they upgrade to 8.1.2 or above. If you are still using SSL for servers that are below 8.1.2 version, nothing's changed there. You would still manually configure that SSL in those servers. Now, if you do upgrade a server that previously had SSL defined and you upgrade it to 8.1.2, the servers will be migrated and we will try to exchange the certificates automatically. If there is a self-signed MD5 certificate on that server, once we upgrade it, and it is not set as the default certificate, that certificate will be removed. If there is a default certificate present in the server cert.kdb, if it's an MD5 signature, then the 8.1.2 server will dynamically enable TLS 1.1, versus if it's a SHA signature, then we're going to dynamically enable TLS 1.2. And then once the certificates are exchanged and authentication has occurred underneath the covers, you're good to go. I know I gave you a lot of detail and this looks pretty complex, but most of this should just occur under the covers without you having to do any type of manipulation on the SSL certificates. Now with the Operations Center, we also are enforcing TLS 1.2 as our default for communication. And for the Operations Center, we need to make sure that in the Operations Center Trust Store, we are storing both the hub server certificate, and if you're defining spoke servers for that Operations Center, that those spoke servers certificates are also added to the OC Trust. And this Trust Store for the Operations Center will be on the machine you installed the Operations Center code. We do have this concept of trust on first use for when we communicate with the Operations Center for the first time. And what this does is it allows for an admin to log on to the Operations Center, and then the hub certificate is going to automatically copy that certificate into the Operations System Trust Store. The limitations on this is that the admin ID needs to be in a session security equals transitional when it first logs on to the Operations Center. And the Operations Center will only allow a single trust on first use only a single time, and then it's going to set a flag to prevent further use. And at that point, you might have to go in and manually add in those certificates. So once an admin ID connects to an 8.1.2 plus server, the admin's session security is then going to be set to strict also. So after the Operations Center is upgraded to 8.1.2, the first time the admin connects and utilizes the trust on first use, it's possible it'll be a monitoring admin, and that will add the certificates to the trust store. Now, if the trust on first use does fail, then to store the server certificate, you can manually install the trust store following the published instructions, and that'll be like with the GSK commands. I did document that and show you how to do it in this YouTube here, so check that out. This YouTube covers both what happens under the covers automatically, and if you do need to do any type of manual certificate insertion, how to do that with the different GSK commands. Okay, so in summary, Spectrum Protect 8.1.2 has upgraded a lot of security features, whether it is the utilization of TLS 1.2 as our default for communication, whether it's how we're storing different passwords, or whether it's how we generate the encryption key for the Spectrum Protect server. Let's switch over and take a look at some client enhancements. For the DSM ADMC admin command line, You can now set the title at the time of connect. So if you see right here, we can now set what shows up in the title bar of a session. And in order to do this, you would do set window title yes. You need to enable that in the DSM op file. And what will happen is once you quit out of this session, then it goes back to its default terminal or whatever it says by default in your header. We've also increased the command history buffer from 20 to 100. And so if you need more, you can increase that with the dsm.opt test flag, dsm admc edit history, and then you'd put in the buffer size. The web client is no longer supported when connecting to an 8.1.2 and above server. This is because the web client Java code was not updated to use the new security path. And so it doesn't authenticate with 8.1.2 SSL-TLS 1.2, and therefore we're no longer supporting the web client. But it will come up with this following error showing that it's no longer supported. ANS 1582 easy. We've made some changes to our ACL access control list when we do backup and archive clients for IBM Spectrum Scale. File restores are now allowed to do system migration from one hardware and operating system type to another. This is a one-time approach. For instance, we see customers who've been backing up their GPF clusters with AIX nodes, and now they want to add in LinuxP Little Endian nodes to the cluster and remove those AIX nodes. The first time they back up those new Linux nodes, they will seamlessly take over the backup state from the last AIX backup performed. And now restores to new Linux nodes will also bring back the correct ACL. So what happens is, if you do this conversion, the first backup from a different operating system will change the file space table. However, backups do not support mixing multiple operating system types on one IBM Spectrum Scale cluster. So the type must be GPFS. These are the combinations we've tested. What we're seeing as most wanted out there is this conversion to Linux PBE. On slide 39, we now support IBM Spectrum Scale 4.21, 4.22, and 4.23. So 4.23 is our newest level of IBM Spectrum Scale that we can back up to IBM Spectrum Protect. Okay, let's change pace and look at HSM for Windows. One of the first enhancements is a filtered driver performance enhancement, where we better utilize the system SMB threads. SMB is your server message block, and it's a Windows protocol in a LAN. So with this improvement, the performance of the remote access during high SMB usage times should be better. We worked with Microsoft, and they recommended that the max threads per queue be increased from 20 to 512. And for a user of HSM, you will basically see no difference, but perhaps a little bit better performance behind the scenes. In 8.1.0 of HSM for Windows, we introduced a search and retrieve filter for the GUI. In 8.1.2, we're taking that technology down into the command line interface as well. So if you do a DSM CLC retrieve or a DSM CLC list, you can now add in this -FA or -FT option. And the -FA filter migration action, and it can be either keep, replace, or delete. And -FT is the filter migration time, and that can be from the lower time limit up to an upper time limit using this specification of time. So you can see down here we did a DSMC list, and we used the -FT and the -FA options, and we were able to filter out the migrated files using those two options. Also on UNIX HSM, we've improved the Spectrum Scale AFM support. So GPFS 3.5 introduced active file management, and this enabled the sharing of data across unreliable or high latency networks. And our DMAPI call sets a new error number, EBADFF, with return code number 1. And it will do this if a file is either AFM dirty or AFM uncached. And that's the files whose contents are not yet present in the cache. And what this does is it prevents the HSM client from punching a hole into AFM managed files that are not ready for migration. So it'll close the gap for short-term AFM changes on files. Also in UNIX HSM, we now have an optional inline copy of the HSM files to backup containers. When you migrate the UNIX files out to Spectrum Protect, you can optionally have those migrated files copied directly on the Spectrum Protect server out to the backup storage pool. Previously, we had this mode MIG enabled, and that was basically allowing us to do that inline copy from the space management pool out to the backup pool. We've now added the new option pre-MIG, which will do this also for pre-migrated files. And we've added the mode off, which will not do the copy from the space management files out to the backup. If your space management is migrating out to a disk container or cloud container, you must set your inline copy mode to off. Another enhancement in our UNIX HSM is dynamic tracing of the recall daemon. You no longer need to restart the daemon if the tracing is enabled or changed. So you can go in and you can change the settings with the dsm-migfs command. And then each daemon type that supports this dynamic tracing will have its own message queue, as you can see here. But each daemon process is going to listen on its own queue. And so the dsm-migfs will then send a message to the right queue and receive a commit for its changes to its own queue. So the net of this is for the tracing, if you make any changes on the dsm-migfs, no need to stop and restart that. Another new addition to our documentation set is a tape solution guide. And this tape solution guide will help users configure a tape-based solution that optimizes storage and supports disaster recovery. It can provide instructions for planning and implementing a data protection solution utilizing tape, monitoring the tape solutions, managing the tape devices and tape drives, and recovering data after a disaster or unplanned outage. This tape solution guide can either be pulled down as a PDF or you can browse it in the Knowledge Center, and I've given you both links here. If you are in the IBM Knowledge Center for IBM Spectrum Protect 812, you will see our data protection solutions, and as you'll see, we now have this new tape solution guide there as well. Okay, and with that, I'd like to go ahead and turn this over to Sean to cover the VMware and TDP pieces.
Hello, this is Sean Sperry. Now, just to get starting, a little background side. As you probably know, VMware introduced vVols at version 6.x, and those vVols are supported through a VASA2 provider, which is provided by the storage vendor to interface with the storage subsystem hardware. Now, Spectrum Accelerate and Spectrum Virtualize both support these vVols in a VMware environment, and the name of the software that provides the VASA2 interface for Spectrum Accelerate and Spectrum Virtualize is Spectrum Control. Now, for Spectrum Protect, which is intended to do backups, what we do is we interface with VMware's APIs to support those snapshots, and which in turn coordinates and communicates with the underlying hardware. The reason I'm discussing this background is in version 8.1.2, we have introduced some new features for data protection for VE in support of vVols. Now, we have supported vVols on VMware since version 7.1.4, and we allowed the backup of VMs hosted on these vVol data stores, but we did not support any of the features that were associated with hardware snapshots and vVols. And in 8.1.2, we've introduced features in data protection for VMware which allow the creation of persistent snapshots on vVols, which you can use to restore individual virtual machines or files within those virtual machines. The persistent snapshots are created on the back-end hardware using this VASA provider. And you can also, just as you've always done, copy those snapshots to the Spectrum Protect server if you choose to for multiple layers of protection should you be concerned that you're going to potentially lose your hardware. So this really provides some of the same functionality that used to be provided by Spectrum Protect Snapshot, but is now included in Spectrum Protect for virtual environments. The management of this function is going to be done through the vSphere client. So you have a GUI that allows you to do the management of it, which you can see over here, the standard vSphere client or vSphere Web Client. And you can also do it through a command line if you choose to, but the web GUI tends to be much easier. So this slide presents some of the features of this persistent snapshot functionality on VMware when used with data protection for VMware. There are basically two ways to do this. One is this so-called backup now capability, which allows the admin via the web GUI to create a persistent snapshot during the backup of a VM hosted on a vVol and optionally send it to the Spectrum Protect server. You can also schedule this functionality using the scheduling feature of Spectrum Protect for virtual environments data protection for VMware. And what most people will want to do and may choose to do is to schedule multiple persistent backup snapshots during the day, and then as an option maybe only send one of those snapshots to the Spectrum Protect server. So maybe you create 3 or 4 or 5 snapshots during the day, and then at night send one to the Spectrum Protect server for longer term storage. Now, obviously from a restore perspective, the restore of these snapshots is likely to be considerably faster than pulling them back from the Spectrum Protect server, because those snapshots are stored directly on the vVol with the virtual machine. We have a special name for this function. It's called a fast revert. So if you do a restore of a virtual machine using data protection for VMware, you will now see this option called fast revert, which allows you to pull the virtual machine from a snapshot on a vVol if one exists. Of course, you also have the same options you always used to have from the Spectrum Protect server of doing a restore, an instant restore, or an instant access. Now, just a note here, because these snapshots are logical, we only allow revert to the original name, so you cannot do a revert to a different name of the virtual machine. Now, from a file level restore perspective, we of course have the self-service file restore graphical user interface for data protection for VMware, which allows end users to restore files inside of their virtual machine. And we wanted to keep that as simple as we possibly could and very simple to use. So really there has been no changes to this self-service interface for data protection for VMware. The users will just see what they always see, and basically they also only see restore points, so they do not see whether the file is located on the Spectrum Protect server or in a vVol based snapshot. And what happens behind the scenes is, if the user picks a file that is indeed in a snapshot, then that will be used to restore the file. But if, on the other hand, they pick a file that is stored on the Spectrum Protect server, then the graphical user interface, and the software will go out there to the Spectrum Protect server, look inside the VM backup to get the file. Application protection support for vVols. As you probably know if you've been working with Spectrum Protect for a little while, that we do support consistent backups of both Exchange and SQL Server when they are stored on virtual machines in a VMware environment. And that is using this include.vm.tsm.vss statement or tag, depending on how you do it and whether you're doing it through the GUI or an options file. Now, when we first introduced vVols, we did not support this function for virtual machines that were stored on vVols, but in version 8.1.2, we have gone ahead and added that functionality to the application protection support. Now, there are a few limitations for this still, and again, this is something we're working on in our agile development, and those limitations are best described by taking a look at this table. So I'm not going to read it to you completely, but just tell you about the features. Basically, we've added support for application protection in VM-based backups where the backup is stored on the Spectrum Protect server. If, however, the backup is stored in a persistent snapshot on a vVol, we will be doing individual database restore and individual mail restore in a future version coming up. Okay. Moving on to some additional features of Spectrum Protect version 8.1.2. And again, this is a slide that should be very familiar if you've been following our releases in Spectrum Protect data protection for VMware. We have been, through the last several agile releases, enhancing the performance and the parallelism of data protection for VMware. So we always did do parallel backup support for multiple VMs in parallel. In version 8.1, we added backup support for a single VM with multiple VMDKs in parallel, and we also add multiple thread support for a single VM with a single large VMDK in parallel. Now, as far as restore goes, that's something that we've been adding as we go along. So in version 8.1, we added restore for a parallel-based restore for a single VM with a single large VMDK in parallel. And the new addition in version 8.1.2 is a single virtual machine with multiple VMDKs on it. So if you have this large virtual machine, say 4 terabytes, 1 terabyte, 2 terabyte, and it has multiple VMDKs, when you go to do a restore now, you will have the ability to restore multiple of those VMDKs in parallel. Still working, and in the future, coming in a future agile release, will be the restoring multiple VMs in parallel from a single data mover. Now, these are the performance options that you can control to define the amount of parallelism you get. VM max parallel, VM limit per host, VM max backup sessions, and VM max restore sessions. These have not changed from version 8.1, but you just get the added functionality of 8.1.2 when you use them today. Okay, so continuing with the version 8.1.2 features, as most of you probably know, we continue to, in almost every quarterly release of data protection for VE, add additional feature functionality to the vSphere Web Client. And version 8.1.2 is no exception. So in this release, we have added certification for the vSphere 6.5 web client in HTML5 mode. We've enhanced the getting started experience through the vSphere client, so it helps guide new users through how to set things up and how to use the vSphere client to support Spectrum Protect. We've added some enhanced schedule history and monitoring panels, which we'll see in a screenshot coming up. We've given more information about load balance use that will help you determine if rebalancing your VMs among node data movers is required. We've moved the mount cleanup for manual unmount situations from the old web-based client to the vSphere client, again, to help you keep users in one single user interface. And we've enhanced both the backup wizard and the restore wizard in the vSphere client to give you additional options, so you can change the properties of a virtual machine when you back it up. And from a restore, we have some additional options that allow you to set a minimum VM configuration and change the provisioning type. I have a few screenshots here that I just like to show you on some of these new features. Here you see the IBM Spectrum Protect Getting Started interface, and again, this is just some getting started information that helps VMware administrators who are new to the product kind of get started protecting databases and configuring the system, and then viewing the schedules and viewing information about what's been backed up and maybe doing ad hoc actions. This is a screenshot of the new monitor panel for Spectrum Protect. So in addition to looking at the status of backed up machines as a whole, we're also allow you to pick a particular schedule. So here you see a schedule that is highlighted is this KHA DC hourly, and you can get further information about the status of the backup in that schedule, the number of VMs succeeded, and the number of VMs failed. So this is overview information on a per schedule basis. So you see here we've selected the schedule, we clicked on it, and you can see the status of the virtual machines in that schedule. You can either sort on status, sort on data mover, or sort on error code, and get information about the various data movers. Now, one of the things that I want to point out here when you look at this schedule is this status screen indicates the overall status of the infrastructure. So that will give you an indication of whether your infrastructure is working. And then you can look at this VM succeeded and VMs failed here. This is not a great example because here you can see we have some failing infrastructure, but here you can see that one VM succeeded and one VM failed in this particular screenshot. So that gives you some further information on a schedule by schedule basis. When you go in and edit a schedule to change the data movers that are associated with it, you will get some additional information about past backups using that data mover. So here you see we've clicked a particular schedule and we've done an edit, and you can see the number of VMs associated with that particular schedule on a particular data mover, the byte data transmitted, and the duration trend. So whether it's going up or down when compared to other data movers. So again, that gives you some further information about how your load is balanced across data movers. And then finally, here we see the ad hoc backup of virtual machine and ad hoc restore of virtual machine dialogues. And as you can see here, we have the ability to override the pre-configured settings for a virtual machine when you do a backup. So for instance, you can change the backup destination. This one's doing snapshots and server. You can change whether application protection is enabled, or change the backup type on the fly. From a restore perspective, we've added a couple different options to this dialog box. One of these is you can do a minimum restore, which does not restore the configuration but only restores the data, which may be useful in some specific circumstances. Okay, so that's data protection for VMware. Moving on to data protection for Hyper-V. We've done a lot of work in data protection for Hyper-V in this release. And as you probably know, if you're using Hyper-V, Windows 2016 introduced new RCT, or Resilient Change Tracking, for Hyper-V virtual machines. This was really done by Microsoft as an improved way to track the changes in Hyper-V VMs, and it really removes the need for Spectrum Protect and other backup products to implement its own mechanism for incremental backups. Really the equivalent to change-based tracking, change block tracking for VMware in Hyper-V. Now, when you're using RCT in Windows 2016, in prior versions you needed this AVHDX file, which was persistent and recorded the changes in order to do incremental backups. When you're using RCT with data protection for Hyper-V version 8.1.2, you no longer need that AVHDX file. So it's really an improvement and much more scalable than previous versions. Now, there are some caveats to the support for RCT and Hyper-V. All VMs must be at the functional level 6.2 or greater, so when you're upgrading to Windows 2016, you may have to consider upgrading the functional level of the virtual machines. The install of this is very easy. It doesn't have a data mover architecture. You just install the product on your Windows 2016 hypervisor. Now, we do support standard and data center hosts in both the desktop experience and server core modes. Currently, we do not support Windows 2016 Nano as a host, but we do support it as a guest in Microsoft Hyper-V. Now, in addition to supporting RCT, we've also added some additional features to the product and to Windows 2016 support when you're using RCT. We have added this include VM snapshots parameter, which will attempt to do consistent data protection of the VMs before switching to a crash consistent snapshot. So basically, when you set this, you set up X consistent snapshots, and then X consistent snapshots, and then it will try Y crash consistent snapshots before doing a backup. Now, in order to use this feature, you do require integration services be installed in the guest VM and also on the host hypervisor. We have added a feature to include and exclude specific Hyper-V virtual disks for Windows 2016. We have included support for physical disks, which is the equivalent of RDMs in VMware, with this VM process VM with phys disks parameter, and this VM skip phys disk parameter when doing a restore. And then finally, as in the previous version, we do expect that most people will implement Hyper-V in a cluster. So you can back up the virtual machines in Hyper-V cluster from any node in the cluster and restore them to any node And with RCT, the VM migration will not impact the incremental backup chain. There is one restriction in the current version 8.1.2, which is that VHD set disks, which are used with guest clusters, are not supported. So clusters are not, those VHD set disks are not supported for guests, but clusters certainly are supported for your Hyper-V infrastructure. Now, in addition to the new support for Windows 2016 RCT, we've also improved the reliability and performance of Spectrum Protect on Windows 2012. We have supported backing up Hyper-V on Spectrum Protect with Spectrum Protect data protection for VMware in Windows 2012 for quite a while. But what we've done in this version is made it faster and more reliable than it was in previous versions by working in the product to reduce snapshot contention from within the threads of the product, and also reducing cross-process snapshot contention for cluster nodes managed through a new retry mechanism. So when you're using data protection for Hyper-V on a Windows 2012 system with 8.1.2, there should be no need for staggered schedules across cluster nodes, and you should see improved performance automatically with the default settings of the new release. Now we have added some new parameters in 8.1.2, including this VM max per snapshot number or parameter that specifies the number of VMs to include in a snapshot, and this VM max snapshot retry, which specifies the number of snapshot retry attempts should there be contention. The default for both of those is 20, and you can increase them depending on the performance of your system. But in trying these in our labs, we found that 20 was a good default for those. So just installing 8.1.2 should see increased performance and reliability on Windows 2012. Now finally moving on to data protection for Windows and snapshot for Windows. There's a couple of enhancements that I'd like to point out in 8.1.2. And remember, data protection for SQL Server, data protection for Exchange, and snapshot for those products are basically the same product, same code. It just depends on where you're storing the backups. So these changes are going to apply to all of those products. Beginning in version 8.1.2, we now support change data capture tables in SQL Server. And you can get the CDC capture tables back by using this either on the command line using this -keep CDC parameter, or in the MMC by changing this keep CDC parameter to yes. Note that this is supported for legacy backups and restored only. It's ignored for VSS restore since you're doing a snapshot restore. And in order for this to be effective and actually to succeed, you have to run the recovery from the data protection for SQL Server interface. We've also included in 8.1.2 a new scheduling wizard, which now allows configuration of the Spectrum Protect scheduler for backup jobs. We used to run using the Microsoft Windows scheduler, which wasn't very robust, so we've added that feature now. It creates and optionally executes a macro on the Protect server when you run this up to set up the schedules. Note that you must have the client acceptor daemon configured and used for scheduling in order for this to work. And then finally, a small enhancement for PowerShell. In virtually all of the previous versions of this product, everything about the product and the backups could be controlled with PowerShell. And beginning in version 8.1.2, the commandlets in the PS module path environment will be automatically discovered and loaded upon use. You used to have to go out there and use a PowerShell command to load these modules up. Now it's done automatically for you, so it's an ease of use enhancement. So that concludes the 8.1.2 enhancements for VE. I hope you found this information useful. I do put out a lot of videos on Spectrum Protect, so if you find this kind of technical information useful, please subscribe to my channel so you can be notified when I put out a new video. Thanks for your attention.